For nearly 2 years, this plane became the most controversial aircraft on the planet. Airlines parked it, passengers avoided it, and many people quietly assumed its story was over. Yet today, it's back in the sky, flying millions of travelers every single day, often without them realizing just how different this jet really is. The Boeing 737 MAX isn't just a comeback story. Hidden behind its familiar shape are systems and design changes that make it one of the most technologically evolved aircraft Boeing has ever built. From engines that quietly rewrite fuel efficiency standards to flight systems most passengers never hear about, the MAX is far more advanced than its reputation suggests. And the truth is, the changes didn't stop at fixing past mistakes. What Boeing built into this aircraft may be shaping the future of short-haul aviation, especially at a moment when its biggest rival is facing unexpected trouble. But to understand why, you have to look under the skin of the plane, starting with the engine that changed everything. At the heart of the 737, MAX is a piece of engineering most passengers never see. But airlines care about more than almost anything else: the engine. And this is where the MAX quietly separates itself from older generations. Boeing partnered with CFM International to create the LEAP 1B, an engine that represents the biggest technical leap the 737 family has ever taken. It uses an advanced composite fan with 18 blades, a much higher bypass ratio, and a significantly higher overall pressure ratio than the older CFM 56 engines. In simple terms, it squeezes more energy out of every drop of fuel while wasting far less of it. That efficiency isn't just theoretical. Operational data shows real-world gains. On short routes, like Boston to Toronto, airlines reported the MAX burning hundreds of gallons less fuel than previous 737 models with the same passenger load. On longer routes, the savings grow even larger. Over time, that difference adds up to millions in reduced fuel costs for airlines and lower emissions in the process. The LEAP 1B also runs noticeably quieter. Its noise footprint is dramatically smaller than earlier engines, thanks to redesigned airflow and advanced acoustic treatments inspired by wide-body jets like the 787. That's a big reason why airports with strict noise limits welcomed the MAX back sooner than many expected. But there was a catch. These engines were bigger, heavier, and mounted differently than anything the 737 had ever carried before. And fitting them onto an airframe designed decades earlier forced Boeing into a series of changes that would quietly reshape the entire aircraft and eventually spark one of the most debated systems in modern aviation. To make those massive engines work, Boeing couldn't just bolt them on and hope for the best. The 737's low ground clearance left engineers with very little room to play with, and the LEAP 1B was far larger and heavier than anything the aircraft had carried before. So Boeing raised the nose of the plane. The MAX received a taller nose landing gear, reinforced to handle the extra load, giving the aircraft just enough clearance to safely operate from the same airports as older 737s. The engines were also mounted higher and slightly farther forward on the wing, a subtle shift that preserved ground clearance but changed how the aircraft behaved in the air. Those changes triggered a domino effect. The wings and landing gear structure had to be strengthened. Portions of the fuselage were reinforced with thicker skins. By the time it was done, the MAX weighed thousands of pounds, more than its predecessor. To compensate, Boeing increased the maximum takeoff weight, allowing airlines to keep the same range and payload they were used to. From the outside, the MAX still looked familiar. But structurally, it was carrying far more muscle than earlier models, built to handle bigger engines, higher loads, and longer missions. And that added strength unlocked something else Boeing had been chasing for years: aerodynamic efficiency. Because once the structure was upgraded, engineers turned their attention to how the MAX sliced through the air. And that's where some of its most overlooked improvements come into play. One of the most noticeable changes sits right at the wingtips, and it's doing more work than most people realize. The 737 MAX introduced split-tip winglets, a design that looks simple but plays a major role in cutting drag and saving fuel. Unlike traditional blended winglets, these split tips combine multiple aerodynamic ideas into one structure. They manage airflow above and below the wing, weakening the vortices that normally rob an aircraft of efficiency. On long flights, that translates into measurable fuel savings and lower emissions without changing how the plane is flown. But the winglets aren't working alone. Boeing recontoured the tail cone, smoothing airflow at the back of the aircraft and quietly eliminating drag that earlier 737s simply accepted as unavoidable. Engineers also removed aft body vortex generators, further cleaning up the airflow and improving efficiency on cruise. Some of these ideas were inspired by Boeing's wide-body aircraft, particularly the 787. Even the engine nacelles carry design cues aimed at reducing noise and improving airflow, blending aerodynamic and acoustic improvements into one package. None of these changes are dramatic on their own, but together they make the MAX noticeably more efficient and quieter than the jets it replaced. And while all of this helps airlines burn less fuel and meet stricter environmental rules, the most dramatic transformation happened where passengers never look. Inside the cockpit, where pilots were suddenly given far more information than ever before. Step into the cockpit, and the MAX feels far less like a classic 737 and much more like a modern Boeing jet. One of the biggest upgrades is right in front of the pilots. 4 large, high-resolution display screens that completely change how flight information is presented. These screens are significantly larger than those on older 737s and match the display size used on aircraft like the 787 Dreamliner. The layout gives pilots clearer situational awareness, cleaner navigation data, and faster access to critical flight information. It's a subtle change, but in high workload moments, that clarity matters. What makes this upgrade even more strategic is how little retraining it requires. Boeing designed the MAX to feel familiar to pilots already certified on the 737 next generation. Instead of forcing airlines into expensive simulator overhauls, the MAX maintained cockpit commonality while quietly modernizing the experience. But this balance, new technology layered onto a decades-old airframe, came with trade-offs. The larger engines and their new position on the wing changed how the aircraft naturally responded in certain flight conditions. And to make the MAX handle like earlier 737s, Boeing introduced a system that would later become one of the most closely examined pieces of software in aviation history. Because what was designed as a background assist would soon move to the center of a global controversy. That system was called MCAS, and it was created with a very specific goal in mind. Because the larger engines sat higher and farther forward, the MAX could develop a stronger nose-up tendency in certain flight conditions. Boeing wanted the aircraft to feel and respond like earlier 737s, so pilots wouldn't need extensive retraining. MCAS was designed to do that quietly in the background. When certain conditions were met, it would make small adjustments to the horizontal stabilizer, nudging the nose down to match the handling characteristics pilots already knew. Under normal circumstances, most crews would never even notice it. But in late 2018 and early 2019, everything changed. 2 fatal accidents. Lion Air Flight 610 and Ethiopian Airlines Flight 302 triggered a global grounding and intense scrutiny of the aircraft. Investigations later reported that MCAS had activated based on faulty data from a single angle of attack sensor. In those situations, the system applied far more stabilizer movement than originally expected, and crews were overwhelmed in a matter of seconds. As the findings became public, trust in the MAX collapsed. Airlines grounded their fleets, regulators stepped in, and Boeing was forced into a level of review and redesign rarely seen in commercial aviation. What followed wasn't a quick software patch, but a fundamental rethinking of how the system worked and how pilots interacted with it. Because before the MAX could ever fly passengers again, MCAS would have to be rewritten, restricted, and placed under tighter safeguards than anyone initially imagined. Fixing MCAS became the key to the MAX's survival. Regulators around the world made it clear this wasn't about restoring confidence. It was about rebuilding the aircraft from the logic level up. Boeing rewrote the system so it could no longer rely on a single sensor. MCAS would now activate only if both angle of attack sensors agreed, and even then, it could trigger just once per event, instead of repeatedly. Its authority was sharply limited, preventing it from overpowering pilot inputs. New alerts were added to the cockpit so crews could immediately recognize sensor disagreements. Training changed too. Pilots were no longer expected to treat MCAS as invisible. Updated procedures, revised checklists, and simulator sessions walked crews through exactly how the system worked and how to respond if something didn't look right. Even physical wiring changes were made to meet stricter safety separation standards. After nearly 2 years of testing, audits, and independent reviews, regulators began lifting the grounding. In late 2020, the MAX was cleared to return to service. Since then, it has quietly rebuilt its presence in the skies. Thousands of flights operate every day, and airlines have taken delivery of more than 1,000 aircraft, with thousands more on order worldwide. For many passengers, the MAX's return went almost unnoticed. But inside the industry, something bigger was happening. Just as Boeing stabilized its most troubled program, the balance of power in commercial aviation began to shift. This time, not because of Boeing's problems, but because its biggest competitor was facing unexpected ones. Just as the MAX was finding its footing again, the wider industry was hit with an unexpected twist. This time, the pressure wasn't on Boeing, it was on Airbus. In late 2025, reports surfaced that Airbus had discovered a manufacturing issue affecting parts of its A320 family, the very aircraft many airlines rely on as the backbone of their short and medium-haul fleets. The problem involved improperly drilled holes in certain fuselage panels, a detail that sounds minor but triggered major concern. Inspections were launched across multiple production lines, and delivery schedules immediately came under strain. For airlines already dealing with tight capacity and aggressive growth plans, even small delays create big headaches. Hundreds of aircraft in various stages of production were suddenly under review, and some jets already delivered were flagged for additional checks. Airbus acknowledged that deliveries would slow, while engineers assessed the full scope of the issue. The timing couldn't have been more awkward. The A320neo directly competes with the 737 MAX, and for years Airbus had dominated deliveries, while Boeing worked through its own setbacks. Now, airlines waiting on new aircraft were facing uncertainty again, but this time from the world's largest plane maker. And that opened a door Boeing hadn't seen in years. With the MAX back in service, production stabilized, and regulatory hurdles largely cleared, Boeing suddenly found itself in a position to offer something airlines value above almost everything else: reliability. Because as Airbus dealt with inspections and delays, Boeing was preparing for its most aggressive production push since before the grounding. And the next chapter of this rivalry could redefine the commercial aviation landscape heading into 2026. Boeing's plan for 2026 is bold. The company aims to sharply increase deliveries for both the 737 MAX and the 787 Dreamliner, signaling confidence that production can scale without the quality setbacks that once plagued the programs. For the MAX, this means moving through a cleared backlog of orders while steadily delivering aircraft to airlines who had waited years for new jets. The 787, meanwhile, benefits from a long-haul demand surge as carriers expand international routes post-pandemic. Streamlined assembly processes and cleared regulatory approvals put Boeing in a position to meet aggressive targets and potentially capture market share while competitors struggle. Airbus, by contrast, is facing a bottleneck. The fuselage panel issue threatens to delay hundreds of A320neo deliveries, forcing airlines to consider alternative options or reshuffle fleet plans. Even a few months of delay in a busy short and medium-haul network can ripple through airline operations, affecting schedules, revenue, and passenger experience. In this context, Boeing's stability suddenly becomes a competitive advantage. But the opportunity isn't guaranteed. Boeing must execute flawlessly. Any new defect, missed delivery, or operational hiccup could erase the advantage it's worked so hard to reclaim. Airlines and regulators are watching closely, and the aerospace market is unforgiving. Multi-year lead times mean that today's decisions shape fleet strategies for years to come. The next 12 months, then, may determine whether Boeing can seize a rare moment of industry vulnerability, or whether Airbus will resolve its issues faster than anticipated, restoring the balance of power. The stakes are high, and the outcome could reshape commercial aviation for years. The story of the 737 MAX is more than a tale of engineering. It's a story of resilience, innovation, and opportunity. From engines that push fuel efficiency to aerodynamic tweaks that shave off every last drop of drag. Boeing didn't just fix the MAX, it transformed it into a more capable, efficient, and competitive aircraft. The cockpit upgrades and flight control enhancements ensure pilots have the tools they need to fly safely and confidently, turning what was once a global controversy into a story of regained trust. Yet the MAX's comeback is unfolding against a shifting industry landscape. Airbus's recent production setbacks with the A320neo have handed Boeing a window of opportunity, but only if it delivers reliably and maintains quality. The next year could redefine which manufacturer dominates short and medium-haul aviation, with the MAX at the center of that battle. For travelers, the MAX may simply seem like another jet in the sky. But beneath its wings and behind its cockpit lies a story of innovation, challenge, and strategic timing that could shape the future of air travel for years to come. One thing is certain, the 737 MAX is far more advanced and far more consequential than most people realize. If you want to stay ahead of the latest aviation stories, aircraft innovations, and industry secrets, make sure you hit that subscribe button and join the Aviation Insights community. Don't miss out on in-depth analysis and behind-the-scenes looks at the planes and technologies shaping the skies today. Tap subscribe and fly with us into the world of aviation like never before.